In the United States, we consume roughly 100 quadrillion BTUs of energy every year. The functioning of our society is intimately dependent on these energy flows. 10 years ago, my colleagues and I looked at the prognosis for climate change, and it looked pretty hopeless. There really was no way out. You either continue to burn fossil fuels and people have a decent quality of life, or you turn off all the oil and gas wells and your life regresses to something worse than North Korea extremely quickly. But since 10 years ago, solar got so cheap that it is cheaper today than the rosiest official predictions had for 2150, that is in 126 years. There is a price of solar energy at which it is cheaper to make synthetic fuel than to dig it out of the ground. As of today, humanity gets around 5 or 6% of its electricity from solar. I predict that by 2042, 95% of humanity's energy usage will be downstream of solar photovoltaic power. My name is Handmer. I'm the founder and CEO of Terraform Industries, and we are building machines that make cheap synthetic natural gas from sunlight and air. There are many, many ways that humanity gets energy, and it is quite clear that in the future we're going to use electricity for more things than we currently do. But when it comes to looking for sources of primary energy that have the ability to increase the available energy for humanity by a factor of 10 or 100 over the next 50, 100,000 years, it's pretty clear that solar photovoltaic energy is well ahead of the pack. And we might ask ourselves, why? Why is that the case? And it basically comes down to cost. Nuclear is advanced technology. It requires a large trained workforce. It requires all kinds of safeguards and regulation to ensure that it is safe, which is largely successful. Nuclear power is one of the safest forms of energy today. But all those provisions do not come without cost, the effect of which is to increase the price of nuclear relative to solar. At the same time, solar is a commoditized technology. It's produced at a vast rate by multiple competing factories. It involves processes that are well understood. The final product has no moving parts, requires no specialized labor to implement, and is essentially safe enough for your children to play with. My contention is that the market here is quite clear, and the market prefers solar. Last year, humanity deployed about 460 gigawatts of solar energy worldwide, which is roughly equivalent to 1 5-acre solar array every minute. And I want to emphasize that in 5 years' time, that will seem like child's play. Historically, solar deployment went up by roughly 20-25% per year. In the last few years, that deployment rate has increased to more like 50 to 55% year-on-year growth. We could easily be in a world where we're putting down 2, 3, 4, 5 terawatts a year by the end of this decade, which is pretty absurd. I think it is a common misconception that deploying solar at the scales necessary to move our entire civilization off of fossil sources would require more land than we have available. That's not the case. The entire world could be powered at its current levels of consumption with about 5% of the land surface area, which is less than 1/7 of essentially uninhabited deserts, and we'd have power to spare. But then we also have to take into account the fact that the growth of solar will continue to catalyze development of more energy-intensive industries, which in turn increase demand for solar. And to be more specific, coal, oil and gas, switching over to a synthetic product made of air, produced using energy derived from solar panels. Chemical energy is roughly 2/3 of our energy intake and a large fraction of our carbon emissions. There is a price of solar energy at which it is cheaper to make fuel than to dig it out of the ground, and that price happens to be around $10 per megawatt hour. On current trends, we will hit that price for solar in most of the markets worldwide. There's a huge opportunity there, and I thought, why is no one doing this? And eventually one of my entrepreneur friends, Patrick Collison, the founder of Stripe, said, if there's a feature of the future that you are hell-bent on seeing be there and no one else is building it, then you're it. If we were able to develop a compact, scalable, manufacturable, compelling product which could convert potential solar energy into tangible fuel, that would be an incredible catalyst for driving forward humanity's sustainable energy production capacity. So a fuel is chemically a hydrocarbon. It is chains of various lengths of carbon with hydrogen atoms around the outside. And those chemicals are extremely flammable and contain a lot of energy. And so when we burn them, we can get the energy out. Our challenge is to figure out how to make chains of hydrocarbons out of sunlight and air. We need a source of carbon. We need an industrial source of carbon that can produce 50 billion tons of carbon per year. Well, there's enough in the atmosphere. And then we need hydrogen, which we can extract from water using an electrical process called electrolysis, which is basically ancient Greek for cutting with power. Electro actually means amber, I guess, but in this case it means splitting water apart with electricity. We take the hydrogen and the carbon dioxide, we combine them in a reactor. The hydrogen atoms come and they rip the oxygen atoms off the carbon dioxide molecule, and then they put some more hydrogen atoms on the carbon atom itself, making CH4, which is methane or natural gas. And then if you want to make longer chain hydrocarbons like gasoline, kerosene, sustainable aviation fuel, rocket fuel, or any number of chemicals, you can essentially transform methane into those chemicals using well-understood processes. But as far as the end consumer is concerned, if you turn on your gas stove or turn on your heater or turn on your internal combustion engine car or fire up a jet engine on a plane, the fuel is almost chemically identical to the fossil fuel that we get out of the ground. The only sense in which it is different from naturally occurring fossil fuels is it has fewer contaminants. This is a 1 to 200 scale model of a terraformer. It's the size of 2 shipping containers. You can drop it into the middle of any solar array, and it turns that solar array into a gas well. Of course, nothing comes for free, right? I want to be super clear here. This is not a perpetual motion machine. You have to put in way more power than you get out. All processes that convert energy from one form to another involve losses. If you take the pure heating value of the gasoline that you put in your car and compare that to the mechanical power you get out when you drive your car, it's like 20 or 30% at best. And so the process of converting water and CO2 back into the fuel is also about 30-something% efficient. So you need a source of energy which is both cheap and hugely abundant. And solar photovoltaic obviously meets that requirement, and that's where the energy is coming from.
Does all of this mean that solar represents sort of like the final stage of the Industrial Revolution?
Yeah, well, it depends on how you define it. When people think of the Industrial Revolution, they normally think of the industrial scale mining and burning of coal, big boilers and steam engines and all that cool stuff. The reason that I say that solar forms the final Industrial Revolution is the sun drops 173,000 terawatts of power on the Earth every second, all the time, continuously. If we get to the point where we are getting almost all our energy directly from solar power, that is it. There's no way we can go to get cheaper energy than that. I think if we can get to the point where every man, woman, and child on Earth enjoys the same energy bounty at the same exceptionally low price that we do here in the United States, that would be pretty extraordinary. And we could definitely call that a revolution. I think for some people today, it is difficult to imagine a world that's radically different, either worse or better. When you look at the graphs of human progress, basically throughout history, almost all of humans existed in a state that we would now deem extreme poverty. I expect that you and I will live long enough to see every last human on Earth raised out of extreme poverty. And that's extraordinary. Now, that didn't happen by accident. That happened because we were able to deliver the benefits of essentially science and technology to almost every nation on Earth. Obviously, there's a lot of progress to be made, and I think that it is incumbent upon us today not to say, well, we're first world, we can sit still, we've achieved it, we've achieved the final state of civilization. We need to continue to plunge forward and push forward to make sure that our grandchildren enjoy a life that is as amazing relative to ours as ours is relative to our grandparents. Right now, we're just beginning to feel the effects of increased rate of warming, increased intensity of storms, increased rate of melting of ice caps and so on. Now is the time to keep a lid on it. Now is the time to shove the genie back in the bottle with the technology that we have at hand. We happen to be the generation that is alive when this is happening. We have to solve it. just as my grandparents were the generation that was alive when the Second World War went down, and they had to solve that. It was not what they would have picked for themselves, but it was kind of what fell in their lap. They did a pretty good job with what they had, and we better damn well do a pretty good job with what we have.